Let's look at the idea of shifting curves. Again, if we know what the basic shape looks like, then drawing the curves should be relatively easy. So if we've got our function, or whatever the basic curve happens to be, and we just add a constant number to it, that would represent a vertical shift. Another way of thinking about it is when the constant that we're adding is grouped with the y. We don't normally put it with the y, we normally move it to the other side because y is the subject. But if you think about it, it's actually grouped with the y because the x is by itself inside the function, and so that constant really goes with the y. And that explains why it's a vertical shift, because y obviously measures the vertical. So when it's grouped with the y, that tells us about a shift which is going to be up or down c units, depending obviously on what the constant is. So when it is grouped with the x then, that tells us about a horizontal shift, left or right. So it'll be left or right, again, depending on whether what the constant is. Now, if you're ever unsure whether it's going to be a left or a right shift, or an up or a down shift, when it is grouped with the x or grouped with the y up here, just ask yourself, what would make this equal to 0? And then that tells you where to move it to. Okay, y equals minus the function x. So if we put a minus out the front, that basically has the effect of flipping it upside down, because all the y values that were positive are now going to be negative, and the ones that were negative are now going to be positive. So it will flip upside down, or reflect in the x-axis, I suppose is another way of thinking about it. As opposed to function negative x, it's a little bit more unusual, this one, but if you do have this situation where you notice, hey, everywhere where there was an x, it's now a negative x, that one will actually reflect vertically. So it reflects in the y-axis. So let's have a look at this one. We know it's our basic parabola because we notice that the x is squared. The 3 is grouped with the x, so we know it's a horizontal shift. Right, so there's our basic curve. But it's going to be 3 units to the right, because if I solve that, I'd go, well, x minus 3 equals 0, that's positive 3. So I'm moving it to positive 3. Whoop, there we go. Now we also have this plus 4, which technically is grouped with the y, even though we put it on the other side. And it goes up 4, because when I do move it with the y, I've got y minus 4, solve that equals 0, we get positive 4. Or I suppose we can simply look at it when it's this one and say, oh, look, plus 4. We're adding 4 to all the y values. So let's shift it up. And there is our new curve. So the vertex is at 3, 4. Okay, same idea. Let's do it with a cubic. This time I have a minus out the front as well. So I know the basic shape is my dodgy looking cubic. Now the minus out the front of the function x tells me I'm going to reflect in the x-axis. So it's now got that shape. Then, grouped with the x, tells me I'm going to shift left 1 unit. So let's move it there. And then we also have a shift up 2 units. And so there is the position of our new curve. What was at 0, 0 is now at the point minus 1, 2. This one's not immediately obvious. We've got to do some completing of the squares to do this one. We've got to do it with both the x's and the y's. The one thing we do know is it's going to be a circle, because both the x and the y are squared, and the coefficient is the same, positive 1 in both cases. So we know it's going to be a circle. So if I group the x's, I know it's going to be half the coefficient of x. So it must be x plus 1 all squared. And I do the same with the y's. Well, half of the y is minus 2, so I must have minus 2 all squared. But of course, I can't just change the question. When I square this one out, I've added an extra 1, so I'll add 1 to the other side as well. And with the y minus 2 all squared, I would have added an extra 4. We'll add 4 to the other side, and we'll also take the other 4 over. All that adds up to 9. So now we can see what we've got. using the idea of shifting, okay, it's my basic circle, x squared plus y squared equals 9. But I've got to shift left 1, because grouped with the x, I've got a plus 1. So that goes left 1. But then grouped with the y, that'll go up 2. Remember, when it's grouped with the y, what makes that equal to 0? Well, 2 would make that equal to 0. So the centre moves up to 2. So there's our circle. It now has centre minus 1, 2. I should have really written the radius in there. When you're labelling circles, they're the two key features. Where's the centre? What's the radius? Okay, exponential curve. Y equals 2 to the power of minus x. Although we should know what this one looks like anyway, but let's do it via our basic curve idea. The basic exponential, 2 to the power of x, we know looks like that. But this is a situation where everywhere there's an x, I've replaced with minus x. So that was the one that reflects in the y-axis. And so there's 2 to the power of minus x. Okay.